still lots of people coming in. But as I said, let's slowly get started. What are we going to discuss today? What's our agenda? A couple of things. You're here probably because you're interested in how to use Erlang using a Python or R. We'll focus mostly on Python, but in R it's very much the same. So many of you are probably data scientists, perhaps less aware of the background about Erlang C, Erlang X. So what we're going to do, I'll start with very short, of course, this is not a webinar or a training on Erlang, but I'll give you, I'll start with one slide of the basics of call center staffing, call center safety staffing, then Erlang X. Actually, Erlang X was the very first product when together with co-founder Arik, we started CCmath already 18 years ago. So that was our very first product, and now it's available in Python and R. But I'll explain to you why we think Erlang X is a big step, a big improvement compared to the regular Erlang C formula. We'll explain you the contents of the package. Then our junior scientist, Berkan, he will give a demo on how to use it in Python. And then there's time for questions. Okay. Many of you might know this face you see here, Erlang. Erlang invented the Erlang B and the Erlang C formula a little over 100 years ago. He was a Danish mathematician who worked for the Danish telecommunications, PTT at the time. So what is it all about, call center staffing? What happens in a call center is actually, if you have the inbound calls, and I'll give you an example, a small calculation in a minute. But the number of people you need is more than what you strictly need to handle the workload that you receive. And what we call net workload is the number of arrivals times the average service time or average handling time. And so that is the amount of work that arrives. Now you want to handle this work in a typical call center with a number of agents. So how many agents to schedule? So let's take an example. You receive calls in 15 minutes, an average handling time of 5 minutes. Yes, then the amount of work that arrives in 1 minute, 16 calls in 50 minutes, so that's on average 4 calls per minute. So 4 times 5, you say, hey, the net workload is 20 agents. Yes? But should you indeed schedule 20 agents? Well, actually, it's not exactly 4 calls per minute that arrive, and it's not exactly 5 minutes that every call takes. There are fluctuations in arrivals and handling time. And to mitigate these fluctuations, you need more agents than 20. And that is exactly what Erlang realized. And he used all kinds of assumptions. For example, using the work of the French mathematician Poisson before. But what he did is he came up with a calculation. And if you would do this calculation, and you can find the formula in any mathematics course or also on the internet, on Wikipedia, on how to calculate this Erlang C. But if you do the Erlang C calculation, then you see that you do not need 20 agents, the net workload, but that you need more agents. And if you require that, for example, that 80% of calls is answered within 20 seconds, then you need 25 agents. So you need overstaffing. So 20% of your agents is on average waiting for calls, but sometimes a couple of calls just randomly arrive at the same time, or a few calls take more service time than average. And then there you might have a queue of a couple of customers. And if you schedule 25 agents, then you have the overcapacity to work away this queue. So that is the basic idea of Erlang C, invented more than 100 years ago. At the time, of course, there were no call centers. At the time, it was about switching, manually switching in the first telecom networks that existed. But this is what Erlang had in mind. Nowadays, this Erlang C is very often used in call centers. You could say it's the industry standard. But is that correct? Well, one of the important things that the Erlang C does not take into account is the fact that if you have to wait, and we all call centers now and then, we all have the same experience. If you call and you have to wait for a certain amount of time, then you might abandon for whatever reason. And the Erlang C does not take these abandonments into account. Now, you might see abandonments as a bad thing because these are customers you cannot serve. So that is absolutely true. But on the other hand, if you're waiting in the queue and somebody in front of you abandons, then your waiting time gets shorter. So actually, abandonments shorten the waiting time. So if you would account for the abandonments, then you would staff less people. Otherwise, Erlang C overstaffs. Yes. And there's another reason why it overstaffs. I'll get to that. But abandonments is an important reason. So we need somehow to adapt the Erlang C to account for these abandonments. And that is what scientists have been working on since the 60s. Going back to a number of mathematicians, and also with together with my co-founder Arik, we worked also on that to make to come up with numerical methods to deal with this definitely more complicated situation. And we at CCmath we call this Erlang X. So and without of course going into the details of the computation. But it's more accurate because it takes into account abandonments. It can also take into account a finite number of lines, perhaps less relevant nowadays with everything based on, if you do not have any more physical lines with a finite capacity, and this is less of an issue. But an important issue is also readouts, because the moment you have abandonments, people might call back at a later moment. Quite often they do that relatively quickly, and you have to take that into account as well. So that means more calls, of course. There is this flow. If you have a very short waiting time, then you have less readouts. If you have a longer waiting times, more people abandon, you get more readouts. But it's also important to include that in the performance model. So. Same example with the same net workload. Now we assume, of course, the moment people abandon, you have to understand their behavior. So you have to know how patient they are, how long they are willing to wait. Yes, and there are all kinds of, interesting statistical calculations to be made to determine this patience. Again, let's not go into all details. That's more for a training, or one of the other webinars also on our website gives some information about that. But let's assume that the average patience of our customers, I see there's a typo, average patience of customer is on average 5 minutes. We missed some words. So that some customers perhaps abandon after a couple of seconds. Some are willing to wait 20 minutes, but on average it's 5 minutes. And then you need not 25, but 23 agents to get this 80-20 service level. So that is 2 agents less on a total of 25. That is, of course, really a considerable cost saving. So it is important, we think, for call centers to move from Erlang C to Erlang X, because it's really more accurate, and it saves a lot of money. Of course, and that is one of the nice things of Erlang X. It also tells you how much abandonments you have. Some call centers prefer not to steer on service level, but on the abandonment percentage, and also the Erlang X gives you an approximation of the abandonment percentage. And here you see a small picture In blue, that's Erlang C. On the horizontal axis, it's perhaps a bit small, but for this particular case, a different case than the number example I gave. But just to give you an idea, on the horizontal axis, you see the number of agents. On the vertical axis, you see the service level. In blue, you see the Erlang C. Somewhat strange behavior, because if you're understaffed under Erlang C, then you get a 0 service level according to Erlang C. That's because the queue grows and grows and grows because people don't abandon. Under Erlang X, if you're a little bit understaffed, well, you might have a high abandonment percentage, but still, sometimes the queue empties and you have a positive service level. Yeah, so in, what is it, purple, you see Erlang X, which is higher, which also means that you staff less to get a certain service level. So for those of you entering late, there will be a recording, and also to accommodate people from different time zones, there's another webinar, a second webinar with the same contents later this afternoon. So the Erlang X, if you dive into the scientific literature, you can find something which is called Erlang A, which handles the abandonments, but not the readouts, not a finite number of lines. And we adapted these calculations, added some features, and that is Erlang X. So Erlang X is an important feature of our Erlang package. And as I said, this Erlang package had, because of, well, the increasing interest of people working in workforce management for Python and also for R, but mainly Python, I think. And we decided, let's make an interface, because that's basically what I did. The package as itself, with its functionality that I'm now going to describe, exists since a long time. But we may now make it easily available in Python. So what's content of the package? Of course, basic Erlang C is in it, with the advantage that it's really stable, and for all kinds of numbers, it gives a good answer. If you implement Erlang C, one of the risks is that you get divisions of very high numbers with numerical instabilities, and we make sure that that's not the case. Of course, there's Erlang X. I gave you a little bit of details about Erlang X. I won't do it for the next two models within the package, but we do have a blending option. So that means that is the situation where you blend inbound and outbound, where you cannot interrupt outbound, and when to schedule outbound. So it helps you optimize blending. Again, in our trainings, but also in an online webinar. If you're interested in that, please have a look at that, or contact us if you want to know more about it. Of course, there are manuals where things are described, but if you're really interested, it might be good to dive into it by one of our trainings. Also, of course, chat, over the last 5 to 10 years, chat became more and more popular. In chat, the challenge is that certain form of parallelism, that agents can handle multiple chats at the same time. So we adopted the Erlang formulas to allow for this situation. Some important features that they have, and that is the second reason why Erlang C overstaffs. And I'll be short about this, but I think this is another important issue. Normally, Erlang C, it gives an integer number. Yeah, so that means the 25 that I just gave, that came out of the Erlang C calculation, or the 23 that came out of the Erlang X calculation, won't give you a service level of exactly 80%. It will give you a service level of 82 or 83%, because one agent less will give you less than 80%. Yes? But so you round up from, well, from some fractional number if you want, but later on you're also going to add the shrinkage, and then usually you round again, so you round twice. So it might be smarter to come up with a fractional number instead of 23, 22.6, with the interpretation that you have one agent that is perhaps 60% of the time available. Yes, and then you get again a more accurate number, and you have to adapt your calculations for that. So that's also a feature And of course, forward and backward calculation, I mean by that, you give the number of agents, you get service level, or you say, no, I want this service level of this number of abandonments, and then it gives you the number of agents. Yes. So that is very shortly about Erlang C, Erlang X, blending, chat, and the features which are useful indeed for call center safety staffing calculations. I forgot something here. What is important to realize is that these calculations run on our servers here in Amsterdam in a data center. So what we build is a connection between the two. Now, if you do calculations for, say, a whole day, every quarter of the day, then you do 96 calculations. And perhaps you're doing the same thing for a whole month or perhaps for a whole year. So you might, with a single piece of code, execute the Erlang formula for thousands of intervals at the same time. Now, our servers can easily handle that. The calculation is quick enough. On the other hand, for the communication, that might, you have to wait for the last calculation to be done and the last communication to be done. That might be a bit slower. So to avoid problems here, we vectorized these functions. So you do not make a loop you shouldn't make a loop yourself and do 96 calculations. Now you have a vector with 96 numbers in it, and you do the calculation, and once, then it's sent in one time to our service, and then it should be very fast. Okay, we're slowly moving towards the demo. I'm not going to give you a lot of details. It's pretty simple. What is important is that you get a user ID from us. You can get that through us. Send the email to support, and they will give it to you really quickly. Then, of course, you have to install the package. Again, this is here for Python. And for R, it's pretty similar. And everybody who uses R knows how to install a package. So that's very much the same. Okay. And this is the moment that I want to give the floor to Berkan to really show you how it works. So I will stop sharing, and then he will open Python and show how it works.
Good morning, everyone. I hope that you can hear me well. Now I'll be sharing my screen, and we will go through some case studies in Erlang calculators. So let's get started with Erlang X. In this scenario, we have a contact center, and we receive inbound calls based on a Poisson process. On average, we receive 240 calls per hour. The average handling time of a call is 3 minutes, and the calls are handled based on an exponential service time. The acceptable waiting time of a customer is 20 seconds, which is equal to 1/3 minutes. So if the customer is answered within 20 seconds, then this service is classified as a good quality service. We have 14 agents, and the contact center has 100 trunk lines. And on average, the customers have a patience of 1 minute. So if they wait in the queue for a long time, they are likely to abandon the queue. But the certain ratio of the abandonments will reconnect again, and this ratio is given as a redials parameter. Okay, so we have all the inputs. Now we can call the functions by writing Erlang, the name of the package, then the name of the class X, then the name of the corresponding performance measure. To see the parameters that we require for this function, you can refer to documentation. And here we see that for average speed of answer, we need forecast average handling time, agents, lines, patience, and retrials. And below, you see the basic explanations of these parameters and their domain. Now, let's run the script. When we run it, we get an overview of performance measures for a single hour. We see that average speed of answer is 0.1 minutes, Agent occupancy is almost 82%, service level is 85%, and abandonments is 9%. If you want to work on a shift of 8 hours and you want to make calculations of multiple intervals simultaneously, then we encourage you to vectorize some of your inputs so that each element of these vectors corresponds to a single hour's measurement. So let's think about the forecast. In the first hour, we have 150, and second hour, 180, and it goes on like that. And you change the number of agents because the forecast of call volume changes, and you made your estimation as follows. When you run the script, you get an overview of results for 8 hours. And just by looking at it, you can detect some bottlenecks in your contact center. For example, in the third hour, we see that the service level is lower than the other hours. So maybe you have an understaffing issue here. If you increase the number of agents in the third hour to, let's say, 12, we see that the service level is increased by 10%. So now let's move on to blending calculators. In blending, the agents also can handle outbound calls, but we have a certain priority rule that the agents can handle outbound calls whenever a certain number of other agents are idle. So this number is given as a threshold parameter. If we have 14 agents and 5 threshold value, so it means that the agent can start handling outbound calls when 5 agents are available. To call blending functions, we need to refer to class name BL and then the name of the corresponding function. In that case, we can also find the average number of outbound calls, and we get the similar performance measures as we did in Erlang X. And of course, in blending calculation, you can also incorporate vectorized inputs so that you get results for multiple intervals. Now let's finally move on Erlang Chat. In this setting, the agents serve the customers through chat channels, and they can handle different chats in parallel. Here we can specify the average handling time in terms of the element of an average handling time array, and each element shows the average handling time of a chat group. So we keep that other parameters the same, and we assume that there are 5 agents that can handle chats. To call chat functions, we need to use the main class name chat and the name of the function. And again, you can refer to documentation to see which parameters are required. When we run the script, we get the results for a single hour. So we saw 3 cases, Erlang X, blending, and chat. Depending on your objective and your current data sets, you can use any of these functions, and you can incorporate your results with current Python algorithms and libraries so that it helps you to optimize the processes in your contact center. But that's all from my side. Now, Her will give you some further details.
Thank you, Berkan. Again, at the end, there's time for any questions you have, but I have a few more slides. Okay, of course, pricing is important. For a basic subscription, we ask 1,000 euros, or I think it's 9.95 a year. We do want to limit the number of calls. So for a smaller call center, you probably do less than 10,000 calls per month. And a call, I mean, if you have a vectorized call of 1,000 intervals, or 100 intervals, which makes more sense, and then that is 100 calls. And to avoid that people share the license code 3 different IP addresses. In certain situations, if you work from home or if you have a dynamic assignment, this is we should have a closer look and perhaps not take this too strict. But this is really to avoid sharing of the license key. If you really want to handle a big call center and use it with many people, then we ask 4,000 euros. Again, this works by making a connection with our servers here in Amsterdam. And there might be special situations where you really want the software to run locally. If you're, of course, this is more work to install that and to ensure security and everything. If you're really interested in that, please contact us, and we'll see what is how we can realize this. Good news is, of course, we understand that you want to try it first and see what the difference are between with methods you're perhaps using right now. So we do have a 1 month free trial. So if you're really interested, just try it out and give us also feedback. And then if you really want to use it for your operations, well, then please contact us, and we'll make sure that you can continue using it. How to get it? Well, as we already said, just send an email to us. That can be either directly to Berkan or just to our support channel, where people could get you a quick ID. You use this and then we'll send you let you know how to get access to this package. Same holds for R. Again, we focused on Python because we realized that that is what most people are interested in. I myself, I'm more of an R user actually, so I have it running on my own laptop in R, and it works very nicely. And also for R, just send an email to support and tell them, of course, that you're interested in the Erlang for R package, and they'll give you the software and a license ID. Some time ago, we sent a package to WWFM. That's a channel on Discord nowadays about WFM. They wrote a review about our package. So you'll get this presentation. Click on the link, and you'll see a review. And one of the things they mentioned about the speed, we solved that by factorizing. So that's perhaps good to know. Okay, my final slide. Not a very long webinar, but I hope it was informative. If you want to know more about the functions, we do have a manual. And again, we also have webinars online with more information. Here, there's a precise description of all the parameters you need to enter. Again, we have a number of webinars about Erlang. I'll come to your question. Yeah, I see 2 questions. We'll get to that in a minute. So we'll both by Yannis and Stella. We also have trainings. We have online trainings. That is this WFM Academy. We also give face-to-face trainings, and actually the next training, a week long, that allows people from different locations to come to Amsterdam face-to-face. We did a lot of online trainings during COVID, still a possibility, but we also see the interest of really exchanging experiences. So that is one of the reasons why we organize another general advanced WFM training. Really more experienced people want to get to the next level of WFM knowledge. After the summer here in Amsterdam, September, it's usually nice weather. We book a room in the city center of Amsterdam. So I think it's really a nice occasion, and also and I'll be and also very well interesting. I think to learn more about WFM. I will be the main trainer together with a few colleagues here at CCmath. If you're interested in other products, we do our forecasting tool. We have SaaS solutions for forecasting and scheduling. Please have a look at our website and contact us if you're interested.